Okay, so today's lesson is a combination of everything that we've used so far. We've already talked about the distance formula. We've already talked about the slope. So today specifically, we've been dealing with sides. So we looked at distances of sides, slopes of sides. Today we're only looking at diagonals, okay? So when diagonals are congruent, the quadrilateral is a rectangle. So if you're a note card person, note taker, I would highlight diagonals are congruent and rectangle because that's what that means. Okay? Then when diagonals are perpendicular, that means the quadrilateral is a rhombus. So for those of you making note cards to know your definitions, diagonals are perpendicular. That is a rhombus. Okay? And then if the diagonals are both congruent and perpendicular, that means the quadrilateral is a square. So again, I would highlight diagonals are congruent and perpendicular, and that means it's a square. So congruent, that is using distance formula, which is why it's pointing to the distance. Perpendicular is looking at the slope, and then once you do those two, you can decide, does it fit a square or not? Okay? So let's look at an example of that. Okay, in number one, let's go ahead, y'all plot those points while I plot them. So if I'm plotting A, I go left 2, down 2. Make sure you're labeling A, B, C, and D. B would be left 1, up 3. C would be 3, 2. And D is 2, negative 2. Okay, so if we read the instructions, it tells us use the distance and slope formulas to test the diagonals and determine whether the quadrilateral with the given vertices is a rectangle, rhombus, or square. So it tells us exactly what we need to be doing. So are we comparing sides? No, we're comparing diagonals. So where do diagonals go? Across. We're going from opposite points. So I have a diagonal AC, and I also have a diagonal BD. So let's look at the distance of BD first. Okay, so I'm going to go up here and I'm looking at B and D, so I'm going to go ahead and label those X1, Y1, X2, and Y2. So that's going to be the square root of 2 minus a negative 1 squared plus negative 2 minus 3 squared. Okay? So 2 minus a negative 1, that gives me 3, and I know 3 squared is 9. Then I do negative 2 minus 3, which is a negative 5. Negative 5 squared is 25. So if I add 25 and 9, that gives me square root of 34. Okay? Now, I need to find the distance from A to C and see if those are the same. So I'm going to label my points X1, Y1, X2, Y2, and do the distance from A to C this time. So that's going to be 3 minus a negative 2 squared plus 2 minus a negative 1 squared. Okay, so 3 minus a negative 2, that's actually 3 plus 2, which gives us 5, and 5 squared is 25. Plus 2 minus a negative 1 is a positive 3. 3 squared is 9. So if the distances of the diagonals are the same, what does that mean? Means it's a rectangle. Okay? Now, I need to find the slopes of both of those. So the slope of BD, they're already labeled for me, so that would be negative 2 minus 3 over 2 minus a negative 1. So negative 2 minus 3, that is a negative 5 over 2 minus a negative 1 is a positive 3. So there's that slope. Then I also want to find the slope of AC because we're trying to see, is it a rhombus? So the slope of AC would be 2 minus a negative 1 over 3 minus a negative 2. So 2 minus a negative 1 is a positive 3, and 3 minus a negative 2 is a positive 5. Okay, are these the same, opposite, or they have no relation? They're opposite, which means they're perpendicular, right? And if it's perpendicular, it means that they are a rhombus, okay? The only way something can be a square, if you look at the front, is if both the diagonals are congruent and perpendicular. Are the diagonals congruent? Yes. Are they perpendicular? So it is also a square. It is all three of them, okay?